All right, let's talk about one of the toughest challenges any growing app faces, picking the right database when you go global. This is one of those big foundational decisions that can seriously make or break your app's user experience, not to mention your budget. So let's picture this. Your app is a hit, a huge success. People are using it all over the planet. First of all, congratulations. But that success creates a brand new, really tricky problem. How do you give all those users, from London to Los Angeles to Tokyo, a fast, snappy experience? And that right there, that's the core of it. It's a constant balancing act. You're juggling four things at once. You want low latency, so your app feels fast. You need strong consistency, so the data is always correct. You need high availability, so your app is always online. And of course, you have to manage the cost of doing all this across the entire globe. It's a real puzzle. Okay, so how do we even start to solve this? Well, every good architect has a toolkit, and in this case, it's got three main types of databases. Think of these less as competitors and more as different tools for very different jobs. So here they are, our three big options. First, you've got your traditional relational databases, your classic SQL workhorses. Think of these as the accountants. Their absolute superpower is strong consistency, making them perfect for anything that has to be 100% accurate, like financial transactions. Then there's NoSQL. These are more like the social butterflies. They're amazing at handling huge amounts of changing, flexible data, like user profiles or analytics. And finally, you have the new heavyweights, globally distributed databases. These were literally built for this global scale problem, designed from the ground up to read and write data in multiple places at once. So you've got your tools, but how do you choose the right one? You need a guide, right? Let's think of it as an architect's compass. It has 4 key points that will guide every decision we make: consistency, latency, cost, and of course, operational complexity. First up, let's talk about consistency. What this really means is a promise. It's the promise that when a user in Tokyo updates their info, another user in London sees that exact same update right away. It's all about making sure everyone is looking at the one single source of truth. But making that promise is expensive. Strong consistency, on the left, guarantees perfect accuracy, but it can be slower because the system has to coordinate and get everyone to agree before moving on. On the other hand, you have eventual consistency. It's way faster because it allows for a tiny, brief period where data might be slightly out of sync across the globe. So you have to ask, do you need the precision of a bank, or is the "it'll update in a second" feel of a social media feed good enough? All right, our second compass point is latency. And this one, well, this is just a matter of physics. Your data is traveling through fiber optic cables under the ocean, and no matter how clever your software is, you just can't go faster than the speed of light. It's a hard limit. The further your user is from the data, the slower your app will feel. Period. And your choices here have a huge impact. With a leader-based design, every single data write has to travel to one primary location. So if your primary is in the US and your user is in Australia, that data is taking a long trip. But with a leaderless design, that user in Australia can write to a local database right there, which feels incredibly fast. Okay, third point, cost. And I'm not just talking about the monthly price on the website. No. In a global system, the real costs are often the hidden ones, the ones that sneak up on you, especially when you start moving data around the world. And here it is, the big warning. Every single time your database in Europe talks to your database in Asia, cha-ching, that's called data egress, and cloud providers charge for every byte. This is the line item on the bill that gives finance departments a heart attack, because those costs can really balloon without you noticing. And just to put a number on it, it's not crazy for a high-traffic app to see bills of over $10,000 a month just for these egress fees. That's a cost that will ambush you if you're not planning for it from day one. And finally, our last compass point, operational complexity. This isn't about servers or dollars. It's about people. It's the human cost. How much work is it going to be for your team to run this thing? Because sure, a global database is magic when it works, but when it breaks, trying to debug an issue across 3 continents in 5 time zones, that can be an absolute nightmare for your engineers. All right, enough theory. Let's put this all into practice. We're going to grab our toolkit and our compass and actually try to architect a real-world example, a global e-commerce app. So our app basically has to handle 3 different kinds of data. You've got user profiles with their names and addresses. You've got the product orders themselves, the actual transactions. And you have analytics events, tracking what people click on. The key thing to realize is that each of these has totally different requirements. Let's start with the most important one, the orders. When somebody clicks buy, that transaction has to be perfect. You absolutely cannot sell the same item twice. This means we need absolute, non-negotiable, rock-solid, strong consistency. So we reach into our toolkit, and the right tool for this job is a traditional relational database. Its specialty is what's called transactional integrity, or ACID compliance. It's just a fancy way of saying it guarantees that a transaction is all or nothing. It either works perfectly or it doesn't happen at all. That's exactly what we need for orders. This probably means we centralize our order database in one spot, and we consciously accept a little more latency for some users as a trade-off for perfect accuracy. Okay, now what about something like a user profile? We need to read someone's name and shipping address really fast from anywhere. But if a user in Paris updates their profile picture, is it the end of the world if someone in Seoul sees the old one for another second or two? Probably not. And that's exactly where a NoSQL database is the perfect fit. It's built for these kinds of fast, flexible reads at a massive scale, and it lets us choose eventual consistency. We're making a deliberate trade. We're giving up a tiny bit of data freshness in exchange for a massive boost in global performance and lower cost. Lower cost because we're not paying for that expensive cross-continent coordination every single time someone views a profile. The same logic would apply to our analytics data too. So before we wrap up, I want to share some warnings from the trenches. These are the classic mistakes, the common traps that even very experienced teams fall into when they first go global. The number one mistake is just over-engineering. Teams reach for the most powerful, most complex, globally consistent database and try to use it for everything, even when they don't need it. They assume multi-region is some kind of magic wand that makes everything fast everywhere. It's not. They totally forget about those scary egress costs we talked about, and they get locked into one specific vendor's proprietary features way too early in the game. And this really gets to the heart of it. The goal isn't to find the flashiest or most complicated technology. It's about making a deliberate, thoughtful, and informed choice that actually fits what your application and your users really need. So I'll leave you with this question to chew on. Is the quote-unquote best database always the right one for your app? The truth is, in global architecture, the best database isn't a product. It's a thoughtful decision. It's a careful balance of all these trade-offs. The right choice is the one that best serves your users and your business, not the one with the most bells and whistles on a marketing page.